Hi everyone. In this video we're going to talk about counting methods and how that relates to probability. This goes with section 7E. So the fundamental counting principle is what we're going to start with. And it's got a fancy name, but it's a very simple concept that basically says if you're trying to figure out how many ways something can be rearranged, all you have to do is multiply the number of things you have in the first category times the number of things you have in the second category. And you can keep doing that for however many categories you have. So for example, if the question wants to know how many different meals could you choose that consists of one of each of the following options, your main course being tacos or a hamburger, appetizer you can choose soup or salad, and for dessert you can choose ice cream, cake, or pie. Using the fundamental counting principle, if we have 2 options for the main course, 2 options for the appetizer, and 3 options for the dessert, then the different meals we could make would be 2 times 2 times 3 for a total of 12 different meals. A lot of times in probability, they use tree diagrams to illustrate how many different ways something can happen. So this is kind of a picture of how these 12 meals all would look. You could pick, for example, a taco, then the salad, and then the ice cream, and that would be 1. Or you could pick the taco, the salad, and the cake, and that would be a different meal. That would be a second way of doing it. You could pick the taco, the salad, or pie, and that's the third meal. And altogether, there's 12 different ways you could rearrange those. It's a lot easier to just multiply the choices you have in each category to figure out how many ways something can be done. If you're trying to arrange things in that same way, but it's repetitious, so you're multiplying the same number over and over again, that's essentially what an exponent is used for. So it's easier to just go to that. Here's an example of that. How many different license plates are possible that have 3 letters followed by 4 numbers? And this picture is just an example of one of the ways that could happen. The first 3 spots are letters, and they can be repeated. So just because we use the A in the first spot doesn't mean we can't use the A again. And the same thing with the numbers. These are going to be single digits, 0 through 9. If you look at how this can be done, since there's 26 letters in the alphabet, you have 26 choices for each of the 3 spots first, followed by 10 choices for each of the numbers. The digits 0 through 9 are 10 choices. So since we're multiplying 26 3 times, we just went 26 to the third, times 10 choices, we're doing that 4 times, that's 10 to the fourth, for a final total of 175,760,000 different license plates. Now suppose you can choose from 5 different shirts, 2 pairs of pants, and 3 pairs of shoes. How many different outfits can you make? This is as simple as multiplying 5 times 2 times 3. 5 times 2 times 3 means you could make 30 different outfits. And then the next one, how many different telephone numbers are there that have a 3-digit area code and a 7-digit local number, but they cannot start with 0 or 1? So here's your picture of all the different ways that this could happen. For the area code, we can't start with a 0 or a 1, which leaves 8 other digits that could be. It could be 2 through 9. The other 2 spots on the area code have no restrictions, so there's 10 choices for each of those. For the local number, same thing as before, you can't start with a 0 or a 1, which means 8 choices for that first spot. But after that, there are no restrictions again, so those are all 10 choices each. When I multiply this together, I see that there are 2 8s and 8 10s. So I used exponents to multiply this out. It's just faster. And I got 6,400,000,000. That's how many different phone numbers you could make. For this next topic, it's a little bit of a different concept. A permutation is an arrangement of items when the order makes a difference to you. You don't use any of the items more than once, and the order matters. There's two different ways we calculate permutations. The first is to use this thing called factorial. A factorial is an exclamation point in math. It means you multiply the number in front to every other number counting down until you get to 1. For example, 4 factorial means, starting with 4, you multiply every number after that down until you get to 1. So 4 times 3 times 2 times 1. If you plug that in separately, you'll get 24. But your calculators have a button on them that'll make this a little bit easier for you. So to plug in something like this into your calculator, I'm using a graphing calculator, but every calculator is pretty much the same as far as how to get to this function. First, if you're trying to plug in 4 factorial, press 4, and then you need to look for, in most of your calculators, it'll say something like PRB. On this graphing calculator, I have to hit math first, and then use my arrow key to go over to get to PRB. But look for the PRB button. You'll see now on my screen, I have lots of different choices here. These are all probability functions. If I go down to this one on my calculator and press enter, I can choose to use this factorial key now. So on your standard scientific calculators, you press 4 first, then hit PRB, and then go down until you see your factorial key. Press enter to choose it, which will put it on your display screen, and then press enter again, and it'll calculate it for you. That way you don't have to spend the time to do this whole thing. You'll get the same answer, but it's a lot faster. Factorials are used to calculate permutations when you use all of the items too. So 4 factorial could be something like this. You have 4 books on a shelf that you want to arrange in a certain order. How many ways could it be done if you use all 4? There's 24 ways you could arrange those books then, as long as you use all 4. If you don't use all of your items, the other way you calculate permutations is to use this thing called NPR. This is done if you're only going to use some of the items in the list. So maybe you're arranging from the 4 books, maybe you're going to only use 3 of them. This would be a case where you would use NPR instead. The N represents the total number of the items that you have, and R represents the number that you're actually going to use. There is a button for this on your calculator as well, and I'll show you how to use that in just a second here with this example. If there are 5 items and we're arranging 2 of them at a time, you calculate the number of ways that can be done by putting this in as 5 NPR 2 and then press equal. On the calculator, it looks like this. The total goes first, so the 5 is first. Then I need to go back to my probability choices, so I have to hit math and go over. Most of you will just press your PRB button and then look at your choices. The second choice in my list is NPR, so I'm going to go down using my arrow key to that. I'm going to press enter to choose it, and then I'm going to put the second value that I'm picking, which will be the 2. Then press equal, and it'll calculate it for you. So 5 NPR 2 is 20, and the calculator will do all the heavy lifting for you. So how many arrangements can you make from the letters A, B, and C using each letter only once? This is an example of a permutation where we're going to use all of the items, all 3 of these letters. since we're going to do that, this is going to be 3 factorial. 3 factorial, when I plug it into my calculator, gave me 6. One more time for practice. You press 3, then go to PRB, and then scroll down till you see your factorial key. Press enter to choose it. Press enter again for it to calculate it for you. If you're curious as to what that looks like, here are all of the different ways you could rearrange those 3 letters. In the next example, it says, how many ways can you arrange 6 books on a shelf if you have 6 places to put them? So again, the order is going to make a difference to us because we're rearranging this, and we're going to use all 6 books. This would be 6 factorial. 6 factorial, when I plugged it in, gave me 720. For the next example, it says, on a team of 10 swimmers, how many possible 4-person relay teams are there? So I'm going to make a team of relay people, which means that the order that I put them in is going to matter. You want the fastest people at the end usually. But we're not using all 10 of them. We have 10 to choose from, but we're only going to choose 4. This is when I would use NPR. Since 10 is my total and I'm choosing 4, I'm going to put this in as 10 NPR 4. And that should give me 5,040. To practice this one more time, you press the total first. So we have 10 swimmers total. Then we're going to go to PRB. We're going to go down to NPR. Press enter to choose it. And then we're picking 4 people for this relay team. So 4 goes at the end, and then press enter. That's where the 5,040 comes from. Next example says, 5 men and 5 women line up at the checkout counter in a store. How many ways can they line up if the first person in line is a woman and the people in line alternate from there, woman, man, and so on? We're arranging these people in a line, and if we switch any person in the line, it would make a new arrangement. So this is a permutation, and we're going to use all of these people, but we're putting them in a very specific order. We have 5 groups of people to choose from for each of this. So since we're using all 5 men and all 5 women, that would be a double factorial. 5 for the men, 5 for the women. You can plug this all in at once. So I'm going to do 5 factorial. I need to go to my PRB selections and choose the factorial button. Then times 5 again, and then back to my probability functions. Choose the factorial a second time, then press enter, and it'll calculate that all at once for you as well. The next example says you are the coach of 13 little leaguers and are putting together a 9-person batting lineup. How many different lineups are possible? So again, because we're talking about people and switching the order of a person or 2 people would change the lineup, this is a permutation. We're not using all of the team though. There's 13 people on the team, but we're only going to choose 9 of them. So this is going to be an NPR type of a problem. The total is 13, and we're picking 9, so that goes second. And we're going to plug that in, 13 NPR 9. And this is how many different lineups are possible. 259,459,200 different Little Leaguers batting lineups. All right, for the last topic of this section, we're going to talk about what a combination is now. In math, a combination has a very specific meaning. We tend to use this word when we're talking about things that are not combinations. But a combination in math is when you're arranging items and the order does not matter anymore. So if you switch something around, it still would stay in the same group. So think of combinations as groups and permutations as lineups. There's only one way to calculate a combination, and that's to use NCR. Whether you're using all of the items or some of the items, you do NCR no matter what. N is still the total, and R is still the number of things that are being chosen. So how many different 5-card hands are possible from a 52-card deck? This is a situation where the order wouldn't matter because whatever 5 cards I choose, once I'm holding them in my hand, if I shuffle them around in my hand and rearrange them in my hand, I still have the same 5 cards. So order doesn't matter of how I'm holding them. When I calculate it then, that means that 52 is my total. I'm going to use NCR because it's a combination, and 5 is however many I'm picking. This looks like this, 52C5. In my calculator, I plug it in the same way as I would for the NPR. Total goes first, so 52. Then I need to go to my PRB choices. And in my list, NCR is the 3rd choice. So I'm going to go down to that, press enter to choose it, and I'm picking 5 cards, and then I press enter. And that's how many ways I can choose 5 cards. Next example says a committee is to be formed with 3 nursing students and 2 business students from a class with 10 nursing students and 8 business students. How many different committees are possible? This is a combination because how we choose the people doesn't matter. The order that we choose them will not matter whether or not they're on the committee. If I pick Susan first and then Jane, or if I pick Jane first and then Susan, they're both still on the committee. The order that I choose them in isn't going to matter. The other piece of this is that you're choosing 2 different groups and then combining them together on the same committee. That means you're going to need 2 different C's and NCRs when you calculate this, and you're going to multiply that together using the fundamental counting principle, as if you're talking about appetizers and desserts. So it looks like this. 10C3 for your nursing students because you had 10 total and you're choosing 3 for the committee, and 8C2 for your business students because you had 8 of them total and you're going to pick 2 of them for the committee. When I plug this in, I got 3360, which you can go right to it on your calculator. So for the nursing, it was 10 over to probability, picking a C, 10C3 times, and then the business students, there was 8 of them total. We're picking C again for that, and we're going to choose 2 of them for the committee. So 10C3 times 8C2 is 3360. And the next one says a political discussion group consists of 12 Republicans and 8 Democrats. In how many ways can 4 Republicans and 4 Democrats be selected to attend a conference? This is another example of combinations because we're sending these people in a group, and it doesn't matter the order that we pick them. It just matters that if they're chosen, then they're going to attend the conference. So this would be 12C4 for the Republicans and 8C4 for the Democrats because we have 2 different groups that we're combining together. So we have 2 C's and then we'll multiply that together. 12C4 times 8C4 gave me 34,650. Plugging this into the calculator one last time. Start with 12. Go to your PRB options, down to C. We're choosing 4, and then times. There's 8 total in the next group. Go back to your probability options, down to C, choosing 4 of them as well, and then press equal. 34,650. And that's the end of section 7E. At this point, now we're done with the chapter, and you should be able to complete the homework sections, the quiz, as well as the practice exam that is also posted to Blackboard. If you have questions, please reach out to me through the Skype meeting that will be set up during our class time. Thanks for watching.